So the way we're actually going to graph for the lab is augmented a little bit because we're not using concentration values. We're using drops of sodium thiosulfate. So the graphs that we went over on Monday, that I previewed on Monday, apply for most kinetic situations, but the lab, we got to do it slightly differently just because it's we're not using concentration values, we're using drops. And the instructions for those graphs are going to be in the lab instructions. So part of what I'm going to be doing today is recording the graphing process using Google Sheets, like the little things that you need to know how to do using Google Sheets. And so I'll give some additional instructions on the graphing. So if you haven't graphed yet, hold off on graphing until I finish recording that video. I'll get it online somewhere between 12 and 1. And I'll give us the next steps on how to finish the graphing. So one of the big things you can do today is take your data from the lab where you're watching and doing the time trials, take that data and put it into a little table, something like this. Now for us, it'll be like drops of thiosulfate versus time. So you'll have a column for drops of thiosulfate. So I'm going to record a video and show you how to set up the data table and how to do the graphs. Now, what I wanted to show really quick is just some of a preview of how we can use Google Sheets to make a chart. So some of you may be actually pretty good at this already, so it might be a little boring, but basically what you do, you can select the title of the columns and the data, and you can go to insert chart. And when you do that, it kind of automatically populates a graph. Now, this might not be exactly what we want. It predicts what you want to graph already, but you notice the time and the concentration are switched. So we got to switch those axes, and we need to, oh, hey, welcome. Yeah. I'm recording this quick little thing anyway, so I'll put it online. So we need to switch our axes. So it says switch rows and columns, use rows, use columns. So let's see, data range, the x-axis needs to be time. And the series needs to be this. So, so if that didn't work, what I'm going to do is put Google, so Excel, first of all, Excel is a lot easier, but this is free. So I'm going to switch, so I'm going to put time first. So I'm going to make sure that my X is first, and let's see if that fixes it now. Okay, so time is on the X and concentration is on the Y. Now, when we look at this concentration versus time graph, this one actually set up pretty well. And we notice that it's a curve. And when we graph this one, it's to check to see if it is zero order. And based on our data, this is just some sample data that I have from an example. So based on this, it's a curve, so it's not zero order. So we need to check the next possible graph. So I'm just going to make this a little smaller. If this is non-linear, then we need to check for first order. It is a first order reaction. So the next thing we're going to do is I'm just going to copy this time down here, and then I'm going to make a column for the natural log of N2O5 concentrations. And one of the cool things you can do with a spreadsheet program is you can do an equation editor. So I'm going to hit the equal sign, and this is the stuff I'm going to detail a bit better later when I record, but basically you hit the equal sign, and this brings up a function menu. So if I type equals ln, it allows us to take the log of anything in this box. So it starts looking all weird like this, and you hit enter. Okay, so this is the natural log of whatever's in this cell, this box. And then I can click this, there's this little square in the bottom right. If I click and drag it, it'll repeat that calculation as it aggregates down these cells. So now, really quick, I've taken the natural log of everything in these boxes. Pretty cool. And then let's go and graph this. Hey, look, it's a line. So this one is linear. And because this plot is linear, we can confirm that it is first order. And the last little thing we can do, check this out. if I go to customize, let's see, grid lens ticks, what is it? I need trend line. So if I go to into the series, I hit a trend line right there, and we want to label it. Use equation. So basically what it's doing right here, it's writing a y equals mx plus b equation. And this value right here next to the x, I'm going to zoom in a little bit, see if it helps out. This value right here, this it's about 7 times 10 to the negative 3. That's the slope of this line. And so now we can experimentally determine the the k value, the rate constant from this slope. And this is a way of graphically determining a k value. So from our lab, we can also determine a k value. The questions don't specifically ask you to do it, but it's just something on the side that we're able to do. So this is essentially what you're going to be doing, producing some graphs. And for your lab submission, I don't have a worksheet that you're filling out. I have a series of sections that you need to do. You need to write your purpose. You need to talk about the materials and the hazards. There's 3 materials, including water. And then the third part's your data section. So that would be a data table. So you just include a data table. You can even copy and paste this onto a Google Sheet. And it will pop up as a little data table. Or you can just do a little print screen. You can just snapshot this and insert it as an image. You don't need all these decimals. If you want to change that and round it off to a smaller number of decimals, you can, but I wouldn't worry too much. It's a long string of decimals, it's no big deal. And then you'll also copy and paste the graphs. Now, from our data, we have 3 trials. And so you're going to have data sets for 3 trials. Looking at the data from the lab, I'm probably going to augment it a little bit where you're actually averaging the time values for all 3 trials. So you have averages. Instead of just doing a graph for each individual trial, I think it'll look a little bit better if we average the data for the trials. So in the recording I'm going to do, we're going to actually look at the data, and then because I have the little spreadsheets that you guys all use, so I'm going to steal someone's data, and I'll do a sample, and I'll walk through what a graph could look like for the lab. So look for that somewhere like around 1 o'clock. I'll get that video online to talk about the next step with the graph, so you can pick up from there and do the work. And then if you finish those graphs, if you do a little attempt on those graphs by tomorrow, that'd be awesome. That way you're pretty much done with the lab and you just need to analyze the data. We'll get back into our groups really quick and you just get to analyze the graphs that you made and come up with some sort of conclusion. So that's the big goal, to try and get that all set up. I did make the lab due on Monday. So if you have further questions, you need more time, you have the weekend to continue working on it. But my thought was we'll have a little bit of time tomorrow to work on some groups. So it'll essentially be done with the lab tomorrow. You just need to clean it up and get it into that the submission format. So it's all organized by Monday.